Hello everyone, welcome back to my channel NetSec. In today's video, I'm going to continue my pen testing lab. I'm going to show you some active information gathering tools. All tools and commands have been listed in this blog post. You'll find the link from my video description. Basically, we are going to discover target information directly by creating some active connections to it. Of course, it will have some chance for the security alarms going off on the target system, or connection requests to the target system will also be logged and can later be used to track you back. Again, please make sure you have the right permission to do active information gathering. Even a very simple port scanning based on this Nmap legal issue page, you may get into trouble when you do scanning. Read this documentation first. You will find lots of interesting things inside of it. Okay, now let's start to learn some tools. Before we start to use the tools, we should know some basic TCP/IP or OSI model. This is OSI 7 layers model. You will find 7 layers: physical, data link, network, transport, session, presentation, and application layer. Another popular model is TCP/IP stack model, which only includes 4 layers. You can see how they are mapping from 7 model to those 4 layers model. The more details about the difference between TCP/IP and OSI model, you can see this table here as well. For information gathering, usually we will focus on data link layer, network layer, transport layer, those 3. Let's start from layer 2, data link layer. There are 2 popular tools in this layer. First one is RPin, the second one is NetSec. So RPin is like a combination from ARP and PIN, those 2 commands. ARP means Address Resolution Protocol. So RPin can directly connect to one of your IP address in the same network. That C means count. So put the number 3 means count 3 times. It will send 3 times of packet. Let's see what's happening. So we'll get 3 packets back. The major thing we will realize here is MAC address for 192.168.2.1 and how many milliseconds spent for this request come back. We transmit 3 packets and we received 3 packets. That's basic usage for RPin. Based on this MAC address, the physical address for 192.168.2.1, we may be able to find out the brand for these devices by using MAC address lookup program. The second command I'm going to talk about is NetDiscover. Basically, this is a network address discovery program. It's based on ARP protocol. It will send out ARP and trying to see the replies and then find out the network addresses. This program can work on 2 modes. One is active mode, another is passive mode. Let's start with passive mode. Basically, just type netdiscover-p. It will listening your network traffic, basically ARP packet, and then see if there's anything coming from there, and then they can resolve it and give you something like MAC address and host name, those kind of information. It will take a little bit of time to collecting those information. At the same time, we can launch Wireshark and take a look. We will run Wireshark on the Ethernet 0, and we're gonna filter in ARP protocol. So now you can see those ARP packets we received on our Ethernet 0 interface, and then most of them gonna be resolved in here as well. As long as we give this commander enough time, they will list all MAC addresses they can find out from your network. So this is passive. We also can do active as well. So net discover. So we're gonna set up the interface, which is -i is net 0, and then -r means the destination for whole network. So then we can select on it's running on active. So it's currently scanning. It shows finish it, but actually it's not yet. They send out packets and then waiting the packets come back, and then they are gonna resolve those ARP packets and then give you those information. We're gonna wait a bit and let it show up. Okay, now we got much more information than we got from passive, and we even can tell what's the system running on it based on the MAC address vendor. So this is VMware system, Intel, Microsoft, and Amazon, Echo B. So that's the network devices running in my home network. So you can see there's a Cisco system, most likely a switch. Again, this is layer 2 command. So it will not cross the network going to different network to find out the machines or network addresses. So that's the problem for these ARP related tools. Just keep that in mind. In layer 3 network layer, we also have a couple of tools use the ICMP protocols to do network discovery. The typical one is pin, which is, I believe, the most widely used network command. I can pin my gateway and you will get the reply come back. Pin listed as one of the top 125 network security tools as well. You can search pin. It's listed as a number 21 based on its popularity for those commands. Pin, telnet, dig, trace route, who is NetSec. Not only you can pin local network, because it's layer 3, you also can pin other network, even internet IP address. If you're using trace route, you also can get each hop from your source to the destination. As you can see, we have 8 hops from my machine 192.168.2.20. We went to our gateway, .1, and then we come out to my ISP and go to internet. Totally 8 hops. Sometimes you get a timeout. That is because that hop is not sending ICMP reply packet back, although they already forward the packet to the next hop, which is 135.0.199.97. This also has discussion either ICMP pin protocol is belong to layer 3 or layer 4. Let's take a look at how it package looks like. So there's IP packet. After that is ICMP packet. In the ICMP packet, it's not like a normal TCP UDP packet you will see. They have port number, source port number, destination number. So from that reason, I mostly believe it belongs to layer 3 network layer. I do want to mention other two enhanced ping command. One is hpin3. You can get all options for this command. You also can search from the menu. Second enhanced ping command is fpin help. You also can find out hpin is listed as a number 15 in the most popular security tools list. It can send out custom ICMP UDP TCP packets and then display any replies. It also can be used as a tool to launch DDoS attack or flooding packet attack to the destination. You can just do quickly hpin test and see what kind of message you will get. This is my gateway, and you also can trace to the internet using the trace route option. You can quickly do DDoS attack using hpin. So right now I'm putting only 10 packets. The size is 120 to destination 175. Only SIM flags packet and the TCP window 64, destination port 80, and flooding the destination, and we are doing random source to hide our real source. So because we are hiding our real source, we won't get any feedback from the destination. This is one way you can launch a quick penetration testing attack to a destination to see if they have enough protection for DDoS. Second command I want to talk about for ping is fpin. Same thing, you can just put the gateway IP there to see if it's alive. Fpin is mostly used for like group ping. You can ping multiple destinations at one time. You just need to put the group -G and then you will get all reachable and unreachable replies from destination. So usually for people to get the alive machines in your network by using fpin, you can just try -Q-A and then you will get the list. And to make this list usable for the future command, you can send it to a text file, and later on it can be imported for other commands as well, such as Nmap, which I can talk about in layer 4 commands. That's the list we got. Layer 4 transport layer. We're gonna introduce two tools. One is Nmap, another is Escape. Both are open source and free software. Nmap probably is another most popular tools used by network admins to try to do the port scanning. So it's simple, easy to use, just Nmap to the target, which is our gateway 192.168.2.1. It's going to take a little bit time, but what we can do is we can using Wireshark to see the packet on the Ethernet 0, and we can filter in based on IP address. As you can see, .2.20 is sending packets to destination. .2.1 and .2.1 also send back reply. It's a TCP packet. They're doing the port scanning right now. We can stop this. Actually, we get everything shows up here. It took us 38 seconds to find out all those opening ports: 21 FTP, 22 SSH. Simple and easy. We also can scan whole network. Nmap 192.168.2.0/24 to make. It's going to take a very long time to get it done, since we already have an active live host list. So we can basically just using that list to launch our scanning. We got fpin text file, so we're gonna let it go and to run based on this fpin list. The second tool I want to really spend some time talking about is SCAPI, which is listing as in a security tool list here. SCAPI number 20. This is a powerful interactive packet manipulation tools. It's written by Python, and it will give you, so as you can see, using IPython 7.20, and the now version is 2.4.4. It is using this interactive Python like interface to let you to manipulating the packets and then send to the destination to see how it's responding back. There's a couple popular packets we can do that is ARP. We have this is case sensitive command. So ARP, and also you can see ICMP packet. IP as well. So those default settings for those packets. And if we want to send out the ARP packets to destination, we have to using command sr1. And then in the sr1 command, the ARP packet, we change the destination to 192.168.2.1, and you will see the reply back packet from our destination. The destination IP became a source IP here, hardware address, MAC address, and then PDST in the reply packet, it's our IP. Similar thing you can do on the ICMP as well. It's a little bit more complicated. So basically, we send out the ICMP packet to 192.168.2.1 here, and then we receive the one answer here. The length is 28. Protocol is ICMP. The source IP is a gateway. So this is layer 3 packet. We have source, destination, and ICMP type is echo reply. If you want to do TCP packet, it's also available here. So this is default TCP packet. We can try to send out the TCP packet to see how it reply back. So we can tell the source is 192.168.2.1 gateway, and then send to Earth destination is TCP source port. When they reply back, they're using HTTP port, so we know HTTP port is opening, and its acknowledge packet is 1. So we send out a flag. This flag is as sync packet, and then we get acknowledge packet. Also, the flag shows it as a sync and acknowledge. Since we didn't reply back again, the TCP IP handshaking hasn't been finished, so this usually we call it half open port scanning. It's by default used by Nmap as well to do that. During we are working on the SCP, we can see we finished our scanning. Nmap scan follows 30 IP address. Totally, we can see 27 hosts up, scanned in about 2 minutes, little bit about 2 minutes. That's all I want to show you today for active information gathering. Hopefully those information are interesting to you. If you like it, give me a thumb up. If you haven't subscribed my channel, please subscribe it. That will encourage me to make more videos.